have not seen it. But most people have. So I won't do it. You might want to take a look at that exceptions presentation. If you have any questions, you can ask in the, we're going to have a Friday morning help session tomorrow, so you could ask then or, whenever. Come up to my open office hour sometime and we can chat about it. Both you guys. Isn't springtime in Syracuse, New York great? I looked out the window this morning and I said, oh, shucks. Syracuse teases you. It gives you a little bit of weather to say, oh, spring is coming, spring is coming, spring is coming. Oh, a snowstorm. Spring is coming, spring is coming. Oh, a snowstorm. I am planning on doing a summer projects meeting. How many people might be interested in participating in summer projects? Raise your hand if you're interested in participating. Okay. So I probably today will announce on Piazza the summer projects meeting. And the idea, you know, it's informal. We get together occasionally in the summer and talk about what we're working on. I talk a little bit about what I'm working on, and you know, you have a chance if you want to. You don't have to, but if you can present what you're working on and basically get a design review of the whatever you're working on over the summer. And you know, it's a nice thing for anybody to do. Take one of your class projects and really, you know, work on the design, you know, reconfigure the design a little bit so you're really, really happy with the design, and make the code, you know, go through the code with an editorial red pencil, you know, getting rid of all the cruft, all the stuff you don't really need, make it nice, simple, clear, plain, so that you can talk about it in an interview. It's a really nice thing to do. And for anybody who isn't all that happy with what they did with one of the projects, is a great, you know, again, a great chance to revisit the design and change your mind about things, and you know, so. But the way it works, 3 weeks out of the summer I spend with my family. I don't do anything. I don't open a computer. I don't look at my email. I don't come to the university. You know, I just spend it with my family. But outside of that, I come once a week. Normally I come once a week, usually on a Friday, and I hold a meeting. I'll send out an announcement. I have a Piazza, Summer Projects Piazza thing. And so, and anybody that wants to, if you want to, you know, you register for it, and then you'll get emails from me. I'm coming in this Friday, or this week I'm going to come in on Thursday, or whatever. And here's what I'm going to talk about. And if any of you want to present, you know, you're welcome to do that. That's the way it works. And so, okay. So today, don't show again. Thank you. We're kind of in cleanup mode. We're going to talk about several things. Didn't do it yet. I'm going to talk a little bit about one WPF topic, and then I'm going to talk about C++ CLI in a little more detail than we did before, finishing up on the really brief discussion we had earlier, and then I'm going to talk about components. So let's start out with this WPF. So somebody asked a really interesting question on Piazza. So for project 4, should I build the directory navigation, you know, the directories and files, as a user control? And that makes a whole lot of sense. That's a really interesting question. You could make that one just a single tab. My original idea was to make just a single tab that had that directory navigation, and I would append to it a little bit of stuff for relationship, you know. But there's several places where it might make sense to use that view. And so building it as a user control is a really interesting idea. My answer to that student was, hey, that's a great idea. I like it. I like the idea. In fact, I am going to do that myself this summer. Now, I am building a repository. I'm going to build your project 4 this summer myself, because I need one at home. I really need a repository. So And I'm going to build that directory navigation as a user control. I think it's a nice idea. I'm going to give it a try. What I said to him was, I think it'll probably take you about as long to build the user control as it would to cut, paste, and edit, cut, paste, and edit, cut, paste, and edit into different tabs. Okay. But if you build it as user control, now it's usable in other places. There's a lot of places, a lot of applications that can use some directory navigation. I mean, it might not even be for directories. If you're careful about the way you design it, you could design it with a provider that provides the directory information and the file information. So, for example, suppose I wanted to navigate a graph, not a directory. So I could have, where I had directories before, now I have a selection of a graph node, and any graph node that's selected, I show the contents of the node in the lower view. So a provider would just, would treat the nodes as directories and would treat the node data as files. Okay, so, but even if it was just glued to directories and files, there's lots of places, lots of applications where you might use it. So what I want to do is spend just a little bit of time talking about what it takes to build this. I just ran this user control. We didn't talk about it much. So let's take a look at first how we use it and then how we build it. So here's this is this demo that did the user control, so I can start it and stop it and reset it and stuff. And what we're looking at is the window so this border is the user control, and so this window has a label, a user control, and a button. And that's what we're looking at right now, is the XAML to do that. So here's the window, okay? And here's a grid, and in that grid I used a stack panel oriented vertically. So first I have my label right here, and then I have my user control, UC1 timer, okay, and I'm going to come back to that. That's the user control. And notice it's just a XAML element. And remember that the tag names in XAML is just the name of a class. So this is a grid class, and there's a stack panel class, there's a label class, and there is a timer class that I developed as part of this project. And there's a button. So, label, timer, button. And in my code behind in this class, I can interact with that button. So here I am in the CS code. I have a function. When I click on that button, I am calling the timer control.reset timer function. So my timer is a piece of functionality. So let's look at the timer XAML. So here's the timer XAML. Okay. Now notice this isn't window, this is user control. So the XAML for this, it starts out with user control, and again the model of a user control is that I'm pulling together other kinds of controls, but I can build anything I want in here. So X class equal user control demo, this is the namespace dot timer, and remember UC colon timer, that's the class name. Okay, so and now here's my timer. So I have here's my control. I have a border. That was that dark border around it, 3-pixel wide dark border. And now I have a stack panel that has a horizontal stack panel that has a text block, which was where I was writing the time, a button to start the timer, and a button to stop the timer. Okay, so that's the layout, but it's done not inside a window, it's done inside a user control. Okay, but I could use a grid, I could use any of the panels, anything I wanted to. It's in a user control, not in a not in a window. The other thing, let's look at the timer code behind now. So here I have a class timer that now derives from user control. This is providing me that control, the ability to be hosted, okay, in that other page. And now I am using a dispatcher timer. This is a class provided by the framework. So this is my class timer. So here's this constructor. So the initialize component is just done. That's the, I get that from the initialize component comes from user control. And I have here's my dispatcher timer T. And so t.interval equals new. I set it for 100 milliseconds. And t.tick plus equals, so I'm defining an event handler for every tick, okay? And here is my, here's my tick event handler using a standard event handler signature, object sender event argz. And all I'm doing is setting, every time it ticks, I'm going to increment my count by 100 milliseconds, okay? This elapsed time is where that area was, where I'm writing the time. I just say elapsed time.text is milliseconds.toString. So whatever I increment, every time I increment it, I just change, that's what's changing that, okay? So, and then I have a function start timer, tstart, and a function stop timer, tstop, and a function reset, and that's what my code is, my code behind in the window is using these functions from the control. So I've taken this little bit of functionality and pulled it out as a control, and now I can just plop it in with UC1 colon timer, UC1 colon timer, UC1 colon timer. Okay, and I can do exactly the same thing with that window. Be bigger, but now the other nice thing about it is that in my GUI, instead of having this fairly big, two-pane window, grid, blah 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 blah, in this tab, in this tab, in this tab, now I have it just in the control, and in each tab I have I have navigator, 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 or something, if that's what I call my control class. So, good idea. Whoever, somebody here asked that question, it was anonymous, so raise your hand if you asked the question. Because I was going to tell you to pat yourself on the back, because it was a good question. Anyway, that's how you build a user control. And I'm going to do that this summer. So if you do the summer, you come to the summer projects meeting, I'll talk a little bit about, how all that played out and how that works. Okay, so user controls, cool. All right, now I want to talk about C++ CLI. I know I talked a little bit, and I don't know how much I said, but would you please just start up? Thank you. So, I think I walked through this slide with you, but the upshot of it is that C++ CLI is managed code. So there is C++ objects model, native code object model, that was built from the ground up to create value types, to allow you to copy, assign, and have unique instances. The .NET object model is not that. The .NET object model is basically, it has a value type just for the primitives and structs. And everything else, anything developed with a class, is a reference type, and you can't make, you can assign and make copies of these and have unique instances, but you can't do that here. All you're doing is copying and assigning handles, and they all point to that same, you can't copy that instance on the heap. Is it impossible? No, it is possible. To make a clone. Sometimes if your class holds just value types, then you can build a clone by creating another instance and copying over the value types, because value types you can copy. If let's call that class clonable and give it a function called clone me. Now you could clone not only a class with value types, but a class that has clone, okay, is clonable, because you would just call clone, okay. So, but at the bottom level, it all has to be all value types. Now, things like dictionaries, you're not going to clone them. Can you? Is it impossible to clone a dictionary? No, that's incorrect. You can clone a dictionary by using reflection. And it is a very painful process. And it will take you days and days to get it right. Okay? So basically, it's not worth the effort. What you want to do is change your design so you don't have to. That's what it amounts to. So the upshot of it is that .NET object model has these reference types, and you should not expect to make copies of them. So that means you use a somewhat different design strategy. Oh, come on. Pardon me 1 second. Yep. So now, C++ CLI is this object model wrapped in what is essentially C++ syntax. So I like to think of it as a sheep in wolf's clothing. If people talk about a wolf in sheep's clothing, this is a sheep in wolf's clothing. But what makes it useful is that you can you can have native code and managed C++ CLI code in the same file, and they can talk to each other. That makes it enormously useful. And that's what I did in the translator. So I want to, slowly go through that and look at it a little bit, just so we can see exactly how that works. I've talked about this before with you. I'm going to skip over it. You can take a look at it if you've forgotten. The libraries are different. So in a file that contains C++ CLI code, when you compile it, you use the /CLR support. And what that does is any reference types are compiled to run in a virtual machine, and the native code is running in a separate segment, the native code. And that means you can use both libraries. You can use the standard C++ library, and you can use the .NET library. And both classes can use them, because native code can talk to managed C++ CLI, and managed C++ CLI can talk to native code, so you can use both libraries, which is nice. because they have different strengths. The .NET Framework class library basically does a very thorough job of wrapping the Windows platform, the API, the Windows API. Really great, very, very well designed, nice support for Windows. And the standard library does a nice job of supporting this. This is a little bit out of date. It says it has no hash table containers. It does have. So it says no regular expressions. It does have regular expressions. I have to update this slide. Sorry about that. But a student from the 8 o'clock session is going to send me a reminder to fix that. And what that means is it'll go in my reminders folder, and this summer I will go back and clean all this up. But anyway, the C++ library has really nice support for streams, no streams in the .NET library, really nice support for the containers. The CLR containers are in many ways nicer than the .NET containers. They both now have support for regular expressions. They both have support for threads, but the threads run in different environments. The .NET thread runs in the managed environment. You can only use .NET threads in a managed environment. So if I'm compiling for a /CLR, I can't, nowhere in that file can I use a C++ thread. Okay. So, but we get the benefits of both libraries. And managed classes, I know I showed you this, but I want to take a minute and just review it quickly. A console application, for example, that has been just created like any normal C++ console application, as long as I change the compilation property to /CLR, then I can define reference types, with a ref attribute. C++ CLI, C# does not, but C++ CLI lets you define a value type as a class. And I think this is nothing more than the .NET struct called a class. Because it behaves, its properties are just like the .NET struct. And there's an interface type, and now N is a native class, and N can hold references to the reference types. It has to do that in a particular way, which I'll show you. I don't know that I have cited that on the slide, have I? But R is a managed class of reference type, and it can hold a native pointer. And here the reference type is indicated with an R hat. So where in C# I would say R, some name, it's lying to you. If you say string something in C#, that isn't a string. It's a reference to a string. It looks like you got a string there, but you don't. You have a handle to a string. But C# CLI makes it clear this is a handle to this reference type, whatever it is, and I create it by calling gcnew on that type, and this puts it in the managed heap. If I want to create a native type, I use new. If I want to create a managed type, a reference type, I call gcnew. Now, I can call, if I define using destructor syntax in a reference type, if I have what looks like a destructor in a reference type, I'm really creating a dispose function. I'm creating a finalizer that will be called automatically by the garbage collection, but I can call it ahead of time by calling delete. This is just like calling dispose on a C# object. and everybody has to remember to call dispose. But C++ CLI did a very smart thing. I can declare a reference type as if it was a native type. I'll say R hat, RH, but I won't say GC new, I'll just say R. This still resides on the managed heap. The only thing that changes is that now when I leave the scope, when the thread of execution leaves the scope where R was declared, delete is called automatically. So it's disposed automatically, so nobody has to remember to call dispose. As long as they've declared it like it was a reference type, they don't have to remember to call dispose. It just happens automatically. I'm going to show you an example of that this morning. V is a managed class of value type, lives in the scope of the declaration. Value types must be bitwise copyable. They have no constructors, destructors, or virtual functions, so it looks just like a struct in C#. I is a managed interface. You do not declare its methods virtual. They are virtual by default. And you qualify implementing classes methods with override to override those. So N can hold values, handles, and references to managed types. The native type can. N can hold values, handles, and references to value types. N can call methods of managed types. R can call global functions and members of unmanaged classes without marshaling. R can hold a pointer to an unmanaged object. So they can, a reference type can have a reference, a pointer to a native type, and a native type can have a reference to a managed type. It looks a little different, and I'll show you in code. I think I may have that on a slide here coming up in a minute. Not yet, but I think I will on the next slide. So now, if I need, so basically the .NET models, when you load a file, it will automatically load MS Core Lib, the core part of the .NET library, but the .NET libraries are huge. And sometimes we'll need some other part. So for example, if I'm going to do some database manipulation, I need system.data.dll, and I can pound include it. Where in .NET, we would add a reference to it and click. And we can nowadays, I can do it the same way with C++ CLI. I can create a reference to it. And we can also pound include the standard libraries like this. And we use a scope resolution operator. So if I want to use a string builder, which is in system in the system text namespace, in a system text namespace, then I'll say using namespace system : text. In C#, I would say using system.text. In managed in C++ CLI, we say using namespace system : text. So it's the C++ syntax. And I declare .NET reference types as pointers to managed types, string hat string. So this is a handle. So str. This clearly says str is not a string, it's a handle to a string, equal to gc new string of hello world. And here's how so in a reference class will normally hold a pointer to another managed type using string hat. In a reference class, I can hold a native pointer to a native type. No problem at all, just use it. Unmanaged classes can hold managed handles to managed types. It does that with this syntax, gc root string hat of string. And this is so, this gc root is here so that the garbage collector will track this pointer. Normally, a garbage collector only tracks references in a managed type. This tells the garbage collector, nope, you got to track this one too, because this is a reference to something on the heap. Okay, and we can have properties and delegates. I'm going to show you some of this in code, so let me just skip over that. Mixed managed code. So let's stop here with the presentation. Some of this that I'm glossing over is a little bit out of date, and this summer I will bring it up to date. But before I turn to the code, I want you to know that this is here. There's a really nice tutorial, C++ CLI tutorial by Adam Sawicki. And this is a little out of date in that there's things that have been added that he doesn't talk about. He talks about delegates, but in .NET 3.5 we added action and func delegates, which are predefined delegates that are really useful, and we use them all the time. We tend to not use delegate something. We use action or we use func. And he doesn't use action and funcs here only because he wrote this before they were introduced into the .NET library. But otherwise, it's a really nice description, very clear, you know, what is it, why do we want to use it, classes and pointers, Windows example, delegates and events, strings, you know. He talks about, you know, he really, using native libraries, using managed libraries, it makes it really, really clear. So, nice introduction, and you might want to take a look at that. And there's some information also on Wikipedia. The .NET functionality is a Windows-only functionality with one caveat. So it's this C++ CLI is a really nice facility to allow native C++ code to interact with .NET libraries on Windows. Now, Microsoft published a core specification, and there is an open source project called Mono that has implemented a lot of the library and has implemented a C# compiler and a lot of the stuff, you know, and you can use C++ CLI on Mono. The issue with Mono is that Mono has these, I don't know, part-time, you know, maybe 50 part-time active developers. And Microsoft has these 843 full-time developers charging away, you know, developing .NET stuff, and so Mono can't keep up. Mono has done a nice job. The core library is pretty much up to date. The compiler is pretty much up to date, but last time I looked, they didn't have WPF and they didn't have WCF and all these nice libraries, which is really, you know, the whole reason we're using C++ CLI here is because we want to use WPF. And I believe that Mono is in the process of implementing WPF. I haven't looked in a while, it may currently exist, I don't know. I know that they don't have WCF, and I don't think they ever plan on implementing WCF, Windows Communication Foundation. But anyway, so let's take a look at some code. So what's here? There's a bunch of stuff. Mixed classes is a demonstration of native classes working with reference classes. This managed classes demo was my first attempt to write a demo. I wrote this code as I was learning C++ CLI. That was my way of learning it. You know, I always learn hands-on. I build stuff, and I try to build it so that I can explain it, you know, A, because I am who I am, but B, it's just a nice way. You know, I think you should try to build examples for yourself that clearly explain it. But anyway, this wasn't a very good explanation. I was unhappy with it, and so I did it again, mixed classes again, and got it right this time. And my intent all along was to remove this and name this mixed classes, and I never got, this has been here for 5 years, or longer, okay? I never got around to removing it, so, but I will, you know, this summer, it's on my list. I'll remove it and I'll just change it. So this is the one, these last three are the ones you should look at. This other stuff is okay, and other stuff there, useful information, but I think this managed app is a work in progress, and I don't think it builds now. But anyway, this stuff is what we want to look at and illustrates everything we need to talk about. So let's look at mixed classes, mixed again. So what I have here is, now if we look at this project, let's make it really clear. So we have, it's an exe, and I started this just as a console application, but you have to set this, if you want to write C++ CLI code, Common Language Runtime Support, CLR. You got to click that on. And what that means is it'll compile the reference types into bytecode to run on a, and put the hooks for the linker so that it runs on a virtual machine and in the CLR. And there's one other property I've forgotten, but I think I have a comment in the code. There's one other property, and I think it's set by default anyway. So anyway, so now notice I'm using namespace system text, and in my references I have a reference to MS Core Lib. And I think you'll find you can't remove that. If you right-click on it, there's no remove. That was put by the framework for, that reference was created for you automatically, and you can't remove it, okay, if you have reference types in there. And so, so that's what lets me access the system type and system text. But, you know, I might need to access other stuff. I can add a reference and come over here to assemblies, and I can add anything I need out of the .NET framework. Okay, there's a lot of stuff that isn't in MS Core Lib that I may need. I don't need it for this demo, so I won't do that. Now, so what I have here is I have a little native class, a normal, you know, and you don't have to name these N, and you don't have to name them R. His name isn't it, but I just for the demo, N1. And it doesn't do anything but say something. Hello. And I have a reference type that's going to hold on to that. So this reference type has a native pointer to this native class. Okay. It will. We'll see. Its constructor will create an instance of native class and set it to that pointer. And it has a finalizer, destructor. Okay. And it has a function called say. And what say does is this say says, hi, I'm a native class. And this guy says, hi, I'm a reference class. And then it calls this guy say. And you say, hi, see, I'm a native class. All right. Just so you can see it talking, the one type talking to the other type. And then I reverse the roles. So now I have class R2 that just says say, and class N2 that now uses GC root to hold a reference to the reference type. And in order to use GC root, I need to pound include VCCLR.h. That's what defines GC root. Okay? So that's all I need to do. VCCLR, and now, every time I want a native class to refer to a reference to be able to talk to a reference type, I need to have GC root. And now in the implementation files, so my native N1 just say hello from instance of native C++ class. And now notice, here's my reference type he's creating using new, so he's creating N1 on the native heap, and which he has to, because that's the only place it'll live. And his finalizer deletes that pointer. And it's his responsibility to do that. He created new, nobody else. So you got a memory leak if you don't do that. Now, and R1 say, console write hello from instance of managed reference types, and now calling method on pointer to native type, and now here I'm calling the native one, and so it's just saying hello. And now here's native 2 that says GC new on R2, the one that's, the R2 is what he was holding in GC root, okay? He's saying GC new, create an instance of this on the managed heap, and delete calls its finalizer. Okay? And then N2 say, just hello from instance of native, calling method on managed type, reference type say. And R2 say just says hello from an instance of reference type. And so, you know, here's, I create R1, R1 say, create N2, N2 say. So let's just run it. Voila! They can talk to each other. Voila! Good. Now, I'm going to skip over P invoke. We're going to look at it, but let me go to RAII. What the heck is RAII? So RAII, people who are proficient in C++ or like to think of themselves as experts in C++, use that term. It stands for Resource Acquisition is Initialization. And what it means is that your constructor and member functions are allocating resources and they're all being returned with the destructor. That's what it means. So it says RAII classes are classes that manage all of their resources. And that's really what you ought to do. And now notice if an exception is thrown anywhere where you're using an RAII class, no harm, because when an exception is thrown, any fully created instance, its destructor is guaranteed to be called, and so it'll release the resources. You won't have any memory leak due to the exception being thrown. So now, but remember I told you that so here's just this reference, reference class, reference type, and all I'm doing is announcing that I'm constructing a reference type. Here in my finalizer, I'm announcing that I'm destroying the reference type, and I have I have an internal string that I can return, and I have a value type that has a save function value type, and here's my main. So what I did in main, remember I said that if I declare this not using GC new, but if I declare this as if it were a local type, as if it was being constructed on the stack frame, it isn't. This object lives on the managed heap. But if I write it this way, what happens is when my thread of execution leaves the scope, the finalizer is called. You don't have to remember to call dispose. These guys did it the right way. Why C# didn't do that is totally beyond me. I think if you wrote a C#, what looks like a destructor or a dispose method in C#, that it should do exactly the same thing. Because now the designer of this class can he's the one who has to get it right. Everybody else just uses the class. As long as they declare it this way, that'll happen. Let me convince you that it does. Notice that this is in a little anonymous scope, so before I write now out of anonymous scope, we want to see this destructor being called. Aha. Voila. Okay. Destroying reference type instance now out of anonymous scope. So, and I didn't say GC new, but it lives on the managed heap nonetheless. Herb Sutter guarantees us that. Okay. So, Herb Sutter was a guy who worked he worked in the database industry for a long time, did lots of threaded, C++ code, building databases, really expert guy, really smart guy. And he was hired by Microsoft, and he heads up their C++ development. And when he came in, there was a managed C++ with a very bad syntax. When you called new, if you called new on a reference type, it went on the managed heap. If you called new on a native type, it went on the native heap. But it wasn't, the code was confusing. Am I creating an instance of a reference type, or am I creating? So he said, if it does something different, make the syntax different. If it does the same, make it the same. And so he had them use the hat instead. So the managed was using star, and you couldn't tell. Is this a native pointer? Is this a managed pointer? So hat is a managed pointer, star is a native pointer. So he got that all straightened out, and now we have this nice facility. Okay. So one last thing I want to look at, there is another way to interoperate, and that's called platform invoke. P-invoke sometimes. So, and what that means is, and C# can do this too. It's not just C++ CLI. C# can use platform invoke. It can't do any of this other stuff, but it can use platform invoke. And platform invoke, normally it's used to pull up code from the platform. This is kernel 32 DLL, for example. I'm going to use its beep function. But this could be your own DLL. You could do a platform invoke on your own DLL. So, I'm just, I am going to use the beep function from the platform API. And so let's set this as startup. I don't have the VGA, the HDMI wasn't working, so you can't hear that because I'm just using VGA. Wait a minute now, it's got a plug, so let me see if I can. It took a bit. Okay. I keep meaning to make it do Mary Had a Little Lamb or something, but anyway. So, that's platform invoke. So, that's really, you now know 80% of what anybody knows about this stuff. There is some stuff about marshalling and, under the covers sort of lower level infrastructure type stuff that you might find yourself digging into. But, several years ago I had a student send me an email and said, you know what? I went into a meeting and he was working for a company that had a whole bunch of C++ libraries, a huge set of C++ libraries, and they had been using C++ UIs and they wanted to convert to Windows Presentation Foundation. And what they were going to do, that meeting was about planning the conversion of all those libraries into C#. And so partway through the meeting, he said, but you don't need to do that. And they said, of course we do. We got to use C#. He said, no, use C++ CLI, and all you have to do is delegate from the C# code to the libraries and back again, and it'll work like a charm. And they did it. So they were planning, they were going to spend a year and a half or something, and then so instead they spent 6 weeks and converted it all. And I hope he got a huge raise because he saved him a lot of money. Okay, but so you might find yourself in exactly that position. Okay, so I want to take a look at some one last set of code, managed examples, before we go on. So I want to take a look at Delegate. So there's a bunch of demos here. We may have looked at this. I know we didn't talk in much detail about the delegates, and I want to talk about delegates a little bit. Did I go through any of this code with you? No? Okay, then let's look at several of them. But I want to start with delegates, because delegates are useful. I didn't think to, but let me see if I can find, there's a diagram I want. Delegate structure. So this is what a delegate, here's the idea behind delegates. So a delegate is a class that internally, its internal code can hold a pointer to a function. You're not allowed to use pointers, but the framework developers are. Okay? So they're patting you on the head and said, you developers don't need pointers, but we, language designers, we need implementers, we need pointers. But anyway, each delegate knows how to hold a pointer. That's the base class. A single pointer to a function, and it has an invoke function, and that will invoke the function. Multicast delegate, all it adds, it derives from this, all it adds is a pointer to another multicast delegate. That's all it adds. Now, you derive from that, and what you are doing is, it's sort of like a template definition. What you're doing is, you're telling it the signature of the function that you can call. Each delegate can only call one function signature. Okay, it's defined by the delegate type. So you're defining here the signature of the function that can be called with this delegate, and now you're going to build a linked list. So here's the publisher holds a reference to that, and you're going to build a linked list of these delegates. So if you want, let's say I have 2 subscribers here, Naga and me. So Naga there's some internal event that's happening inside this publisher, and Naga has something he wants done when that event occurs. So he will subscribe to this delegate, and he will name his function that does whatever it is he wants. And I I also want to respond to that event, but I want to do something different, and I'll define my function. They have to have the same signature, but they can have different contents. Okay. Now, so what happens is that the publisher has initially a null pointer here, and so when Naga registered his delegate for it, now that pointer points to one delegate. And now when I register for it, his delegate now points to me. So when the publisher publishes that event, it goes to Naga's delegate and calls it, and then it goes to my delegate and calls it. Now, and that's nice functionality. The downside of that is if Naga throws an exception, I'll never be called. If Naga throws an unhandled exception, I'll never be called. There is a way to avoid that. I can go into the delegate and I can say, give me your delegate list. And I can walk down the list myself inside a try-catch block, okay, and call them all. Anywho, that's the way delegates work. And the idea is publish-subscribe model. Publisher knows about some events. Normally this is a library function, and the subscriber typically is an application, and the application doesn't know when the event will occur, but it does know that something has to happen, some application-specific thing has to happen when that event occurs. Okay, now, so here, what we're going to do is we have this ref class, demo delegates, and all of these, I wrote these as I was learning C++ CLI. These are all things that I tend to get the syntax wrong. I don't always get it right for arrays. I don't always get it right. Delegates I find the hardest time, I have the hardest time getting it right. And so, you know, when I was learning C++ CLI, I just wrote this example and I saved it away so that I had some place to go to find it. So, so now here's my ref class demo delegates. So this guy is going to be both publisher and subscriber. Here, I am not declaring an instance of anything. I'm not declaring an instance of anything. I'm declaring a type. This is very like this. What's happening here is just like if I had written class del type colon delegate. I derive from delegate. Okay, actually it would say colon multicast delegate. And then some stuff. But that stuff there would handle function pointers, and I'm not allowed to do that. So instead, this is a inconsistency in the language. Any other reference type I create with a class, except for delegates. Delegates you create with this, and this is telling it that I want to invoke functions that don't return anything and accept a string as an argument. Here, I'm declaring an instance, a handle to an instance of that delegate. Right now, it's null. Starts out life as null. So here's my del type hat. So here's a pointer to a del type, some instance down on the managed sheet. And now here's the part that's acting like the application, the subscriber. Here's my event handler, string. And this is this is a guy that's going to be called. He returns nothing, accepts a string, just like this syntax. And I'm just, writing out my del invoked with string, whatever the string was. And here's the publisher publishing these events. So he's just saying, if demo del not equal null pointer, demo del invoke, hi there. You're only going to see one because my main only has one subscription. But if I subscribe to it again, you'd see two. But you have to make this test because he starts out life as null. So if nobody subscribes to this and the event happens, and I come down here and invoke this published event, what will happen is I'll throw an unhandled null reference exception. So you got to make this check. If demo del not equal to null pointer, demo del invoke hi there. And here's the main. So notice that here's delegate demo. I'm just creating an instance of the publisher, and now I'm saying, now here I am. My main is acting as the subscriber. Demo del. So I'm getting a handle on that publisher's handle to a delegate, and I'm saying GC new demo delegates del type. I'm creating a new instance of the publisher's delegate type, and with the and now what I say is here, here's the object. I got to pass him this object, okay, and that's the publisher's object, and I pass him the handle to the pointer to my event handler. Okay, so, and this is a syntax I didn't get right, you know, because, but now, demo publish event, so let's run it. My del invoked with string, hi there. Now, I could have said equals, and this would work just fine. But if somebody else came along and also said equals, they would blow my subscription away. But if you always say plus equals, okay, then it won't blow somebody else away. In fact, let me demonstrate that by, let's just do another one. Wiley. Now let's change this to equals. I did 2 subscriptions, but my second one blew away the first one because he assigned it to it. Now, there is an event syntax declaring the delegate instance as an event, and that event takes away some of the interface of delegates. You can no longer assign to it. That's not, you know, that disappears. So you can't blow away, if they're qualified as an event, you can't blow away the you know, another subscriber's subscription. I tried sticking the event syntax up here in the 8 o'clock class this morning, and it didn't work. There's something wrong with my syntax, so I'll fiddle around with that sometime and add it to that. But anyway, that's delegates. Now, so since I think .NET 3.5, we have these nice predefined delegates, action and func. And you've seen me use action several times in helper code I gave you for Project 3. I used it in the server prototype, and I used it in the client. No, I didn't use it in the server prototype. That's native. I used it in the client. Okay. I use standard function in the server. Okay, but mostly these days people use either action or func. Func allows you to return a type. Action always returns void. It's the only difference between them. They're both variadic templates, and so I can have any number of template arguments. Okay, so if I have an action with no arguments, it says I'm calling a function that returns nothing and takes no arguments. If I have one type, it's a function that takes an instance of that type. If I have two types, it's a function that takes two instances of those two types, and so on. Blah, 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 blah. Okay. So let's take a quick look. There's a demo arrays. And this just shows you how to build and use it. This is a single dimensional array. Here's how you build a rectangular two-dimensional array. I called it matrix. You can also build ragged arrays, and those ragged arrays are really, they're a single-dimensional array of single-dimensional arrays. So what for a ragged array is just an array that can have, in its columns, it can have different sized rows in its columns. Okay. But for a square array, that's the way it's written and used. And this shows you how you pass that. How do you pass an array to a function? So this shows you how to do that. And how do you index it when you're using it? So that's the syntax that's illustrated in demo arrays. An indexer is the .NET equivalent of operator bracket. And both operator bracket and .NET indexers really are the same kind of animals. They both take two columns of things, an input column and an output column, and there's a one-to-one relationship between them. You give me this input, I'll give you that output. You give me this input, I'll give you that output. The operator bracket works that way, and indexers work that way. So, and the indexers are really implemented like a property, and I should have done properties first. So they have a getter and a setter, but here you're getting a whole bunch of things and setting a whole bunch of things, and so that's indexers. Properties, so there are genuine properties because this is a .NET, even though this is C++ CLI, it's a managed model, and so we can define properties in two ways in C++ CLI. There's a long form. You can do the same thing in C#. There's a long form that provides you a get function that you can put whatever you want here in this get function, and as a set function, and you can put whatever you want in these curly braces. And the whole point of this is that you may want to do some validation on an input, or you may want to alter an output in some circumstances or something like that. You can do it, and you can do it without changing the interface to clients, because here I just say property string hat name, and if I need to change it, I can go and change it in the class, and I don't affect any of the client. The clients still call it exactly the same way, even though the behavior has changed a little bit. I might have decided that I want all my strings to be lowercase for some reason, and so I can change all the whatever in the getter or the setter, either one. I can just convert them all to lowercase. So, and there's a shorthand. I could just say property string hat other name, and this is the default. So, what you have is an there's a backing property here. In this case, it's underscore name, this private thing underscore name. And all it's doing is getting and returning that, that name, but this property is a shorthand way of writing this. But if I need to change what these getters and setters do, I have to have this long form. I can't do that in the short form. But as long as I want the default, I can just use this short form. In C#, you'd say string hat other name get set. It wouldn't use property. It would just say string hat name get set, and that would indicate that it's a property. This is the way we do it in C++ CLI. And so, here, DP name equals Bartholomew. I just use the setter. Console write DP name. I just use the getter. It looks like it's public data, but it isn't. It's encapsulated. It's a property. Types. I'm going to do something very similar to this. I already did something very similar to this when we did array. We looked at the is-char and all that sort of stuff, didn't we? We'll look at it again when I talk about template meta programs. I know I showed you that. Everybody's looking blank, but anyway. So I'm going to skip this for now because we'll see the native version of that form, of that stuff. Okay. So what's here? So the first code we looked at is an example of the interoperation between, and as simple as I could possibly make it, the interoperation between native code and managed code. And I showed you that the RAII property works, that I can declare it so it looks like a local data, even though it's really not. And it behaves, the structure is called. And this demo is just here to help you with the syntax for arrays, help you with the syntax for delegates, with indexes, with properties. So it's really here to help me, and I'm passing it along to you. Okay. Did I talk about this tutorial? I did? Good. All righty. With that, I am done talking about C++ CLI for this semester. I want to go now and talk briefly about components. We won't talk long, but I want to talk about components. So here's the model for components. I have a piece of code that has an interface that other code uses, and it has a factory to generate any instances that are needed. So there's one class that implements as an interface, but this class may have some helper classes it needs, okay, created. And so this factory creates, this class might create these itself, and so the factory would just create this one, but whatever's needed here, the factory just creates whatever's needed for this guy to have the functionality he needs. And this component can have more than one interface, by the way. I showed you that earlier, a few weeks ago. I showed you that we could have a class that provided a core interface, but we could add new additional interfaces, and we can get to them by querying back and forth. So, a component could have more than one interface, and we would access those different interfaces in exactly the same way. So, so the model here is that this is totally isolated from any other component. And you'd like this to be self-contained, because you want these to be reusable parts. When you pick one up, you don't want anything hanging loose. You just pick it up and you plunk it down someplace else that you need that functionality. If you pick it up and there are 43 things that it depends on, it's not very movable, okay? Not easy to plunk it down somewhere else. So ideally, it's just one thing. Microsoft has implemented a technology called COM, Component Object Model, that it is pervasively used throughout Windows. For example, the directory management stuff is used by many tools in Windows, and it's all done with a component. There's a COM component that handles all those directory manipulations. There's actually a family of them, but there's one gateway component, and everybody else uses it. And the idea is that that component, in Windows, the directory component, as soon as somebody uses it, it comes into memory. it's implemented as a DLL. So that DLL is loaded. That code is injected into the process in the ways we've talked about. I've shown you diagrammatically. So that directory guy gets loaded into memory, and as long as there's more than one person using it, it stays in memory. And if one person says, I'm no longer going to use it, he'll call release. And what that means is these guys have a reference count. And when it's first